Good evening, dear students. Today we will continue our discussion on matrices from where we left in the last class. So before I start the class, I just want to hear from one or two of you that you are able to hear my voice very clearly and able to view the
Yes,
screen
sir.
properly. All right, thank you very
Yes, sir.
much. Okay. Now, what we start with algebra of matrices is first we are going to discuss with we will discuss addition of matrices, multiplication of a matrix by a scalar. We'll discuss about the properties of uh, you know uh, matrix multiplication, difference of matrices, and properties of matrix addition, and other relevant topics, properties of scalar multiplication of a matrix, and then after that we'll start with matrix multiplication. So to start with, addition of two matrices. Addition of two matrices is possible if both are of the same order. Okay, so let me first keep the note in front of you. After that I'll explain that you know addition of matrices is possible. Okay, that suppose there are two matrices A and B, then addition of two matrices A and B are possible only if they to be of the same order. Okay, if both of them are in the same order, then addition of the matrices is possible. For example, A is a matrix of order 2 by 3 and another matrix B is getting added with it, then B should also be of order 2 by 3. If the order of the matrix B is not equal to that of A, then A plus B is not possible. Okay, that means if we take a matrix A which is order 2 by 3 and we consider another matrix C which is of order suppose 2 by 4, then what we can say is that A plus B possible, but A plus C is not possible to have. The sum of two matrices of the same order is the matrix whose elements are the same of the corresponding elements of the two matrices. For example, if the matrix A is of order 2 by 3 as we see, and the matrix B is order 2 by 3, then we can say that A plus B is possible. And as A plus B is possible, what will be the order of the matrix A plus B? Dear students, the order of the matrix A plus B also will be 2 by 3. That is the property of matrix addition. The sum of the two matrices, that's what I said, the sum of the two matrices of the same order, okay, is the matrix whose elements are the sum of the corresponding elements of the two matrices. If A, that is Aij, M cross N, and B, Bij, M cross N, then A plus B is equal to Aij plus Bij, M cross N. So that means both, the element of the matrix A and P are corresponding elements are getting added. Let's take an example. If you see the matrix, here is a matrix of order 2 by 3, where the first row elements are A1, B1, C1, and second row elements are A2, B2, C2. And that is getting added with another matrix whose first row is P1, Q1, R1, and second row is P2, Q2, R2. Once we add these two matrices, then what happened is that we get a 2 by 3 matrix. Okay, we get a 2 by 3 matrix, and in that 2 by 3 matrix, what we can say is that the corresponding elements are actually getting added. How corresponding elements? So A1, which is in the intersection of the first row and first column of the matrix, first matrix, is getting added with the corresponding elements, that is the intersection of the first row and first column of the second matrix. So A1 plus B1, that becomes the resultant a matrix first element which is in the first row and first column. So in simple term, what I can say is that if I explain it in little elaborate manner, if the first matrix are having A1, B1, C1 and A2, B2, C2, if you see, this is the first matrix, and then the second matrix is actually, we are writing is that P1, Q1, R1 and P2, Q2, R2. So if you look into it, dear students, both the matrices are of the same order 2 by 3. The order of the matrix, if we tell this matrix as matrix A and this matrix as matrix B, so order of both the matrices A and B are 2 by 3. Then how we are going to get their addition? The rule is that to get their addition is that I am going to get another matrix, and that should also be of order 2 by 3. That is for sure. This order is 2 by 3. This order is 2 by 3. As both the order of both the matrices are same, so addition is possible. So the resultant matrix means what we are going to get after the addition, that should also be of order 2 by 3. Now what will be the elements? Element is that, if you see that A1, let me use a different color. A1 is the element, okay, which is in the first row and first column. P1 is the element which is in the first row and first column for the second matrix. Then the resultant matrix, which is A plus B, its first row and first column should be A1 plus P1. A1 plus P1. In the similar manner, we get the element in the first row second column is the addition of the first row second column element of the matrix A, which is B1, with the first row second column matrix of the second matrix, that is a B, that is Q1, B1 plus Q1. In the similar manner, we can get C1 plus R1, and we get A2 plus P2, B2 plus Q2, and C2 plus R2. I hope it is clear, dear students. And as an illustration, as an example, I actually keep this one. Suppose this first one matrix is that 1, 2, 3, 3, 4, 5. Row wise, the first row elements are 1, 2, 3. Second row elements are 3, 4, 5. And the second matrix, its first row elements are 0, 1, 2. And the second one is 2, 3, 4. Now, once we are going to add these two matrices, what we are doing, dear students, is that we are adding the corresponding elements. That 1 plus 0, then 2 plus 1, 3 plus 2, 3 plus 2, 4 plus 3, 5 plus 4. And if we add them, then what we are going to get? 1, 3, 5, 5, 7, 9. And as you see, both the matrices, those matrices which are actually perform the addition operation, are having order 2 by 3, and the resultant matrix is also having order 2 by 3. So this is the fundamentals about the matrix addition. Now the second point what we are going to discuss is that multiplication of a matrix by a scalar. So what it is, that let me show it to you by means of an example. And here it is, dear students. So let me go to the next page and explain you the multiplication of a matrix by a scalar. So how we can multiply a matrix by a scalar. If Aij M cross N be a matrix, okay, and K be a scalar quantity. Scalar quantity means what, dear students? Scalar quantity means is that it is a real number. It is a real constant. Now, what we are going to achieve? We are going to achieve the Ka. Okay, Ka or Ak is the matrix of Kij M cross N. That means each and every element in the matrix is actually getting multiplied with this scalar quantity. As an illustration, if you see that we have a matrix ABC, and we have a matrix whose first row elements are ABC, second row is PQR, So if I explain you, suppose we have a 2 by 3 matrix. That means it has 2 rows and 3 columns. So first 2 elements are A, B, C, and the second 2 elements are P, Q, R. Then what happened, dear students, is that if I multiply this matrix by a scalar quantity K, then what we are going to get? We are actually multiplying that each element, that is A, B, C, P, Q, R, with the element K, with that scalar quantity K. That means what? That is equal to K into A, K into B, K into C, K into P, K into Q, and K into R. So that means when you multiply a matrix with a scalar, the resultant matrix is a new matrix where each and every element is actually multiplied with that scalar quantity. For example, if you see the matrix that is 1, 2, 3, 3, 4, 5, that is a 2 by 3 matrix, and this matrix is getting multiplied with 2. Then what happened? As we just learned, that each and every element of this matrix, that is row wise, if I read 1, 2, 3 and 3, 4, 5, each and every element is actually getting multiplied with 2. That means the resultant matrix what we are going to get is that it is, as you see here, 2 into 1, 2 into 2, 2 into 3, 2 into 3, 2 into 4, and 2 into 5. And if you simplify it, it is actually 2, 4, 6, 6, 8, 10. This is the resultant matrix. And here also it is quite obvious. Suppose I have a matrix A of order m by n. Suppose I have a matrix A of order m by n. That means what? It has m number of rows and n number of columns. Now, if I multiply that matrix with a scalar quantity K, then what we are going to get? I am going to get a new matrix Ka, and the order of this matrix Ka should also be m cross n, like the order of the matrix A. That means after multiplying that matrix with the scalar quantity K, the resultant matrix what we are going to get, that also has the same order as that of the matrix A. This is an important piece of information and the concept what we have learned, that multiplication of a matrix by a scalar. And you know, dear students, that will help us, to find that how to find the, difference of, matrices. For example, we want to make, the difference, there are two matrices, A and B, are of the same order. And what we are going to do, dear students, is that we want to make the difference between these two matrices, that is A minus B. For example, what I am going to say is here that, suppose I have a matrix A. And the order of the matrix A is m cross n. And I have another matrix B of order m cross n. What is my task at hand? My task at hand is that we need to find the value of A minus B. Then from here, we can find the value of A minus B. One thing is for sure is that the order of the matrix A minus B should also be m cross n. That is for sure. But how to find it? How we can do it? We can do it in just by means of the two things we have learned today. One we learned is that matrix addition, and second thing we learned is that multiplication of a matrix by a scalar. That means what we can write? That we can write is that A plus of minus 1 into B. Isn't it, dear students? That means I have a matrix A, and then I have another matrix B. Then first, to find A minus B, what I'm going to do? First, I will multiply each and every element of the matrix B by minus 1. Then what about the resultant matrix? That matrix I can add with the corresponding elements of the, matrix A. Let's take an example that will make our things clear. Suppose we want to perform, this difference. Okay, I'm just going to show you here. We want to perform the the difference of this thing 1 2 3 3 4 5, and the second matrix is that 0 1 2 2 3 4, as you see here. So these are the matrices. Now how to perform the difference of them? As I explained, dear students, so what I'm going to do here is that I'm just keeping the first matrix as it is, that is 1 2 3 and 3 4 5. Then what I'm doing is that the second matrix, as if I'm multiplying that each and every element by -1. So 0 multiplied with -1 becomes 0. But here it will be -1. Here it is -2. Here it is -2. Here it is -3. And here it is -4. We have learned few minutes back that how to multiply a matrix with a scalar by a scalar quantity, and we just applied that knowledge to find the value of this -1 into the B. If we assume this as the matrix B, second matrix is B. And we already aware of what is matrix addition. What is matrix addition? It is the addition of the corresponding elements subject to the condition the order of both the matrices are same. Here we see this matrix and this matrix both are of the same order, 2 by 3. So definitely their addition possible. What is that addition? 1 plus 0, 2 minus 1, 3 minus 2, 3 minus 2, 4 minus 3, 5 minus 4. Now if we simplify, what we are going to get, dear students? We are going to get 1, 1, 1, and here also get 1, 1, 1. So we get a matrix 2 by 3 where each element is 1. So then this is the way we find the difference of two matrices. So if I now write down the theory, so the theory, underlying theory between the difference of matrices are something like this. The first one is that difference of two matrices A and B are possible only if they be of the same order. That means if order of the matrix A is m by n, then the order of the matrix B must be m by n in order to have A minus B defined. If the order of the two matrices are different, okay, then A minus B is not possible. Like A plus B also not possible. So how to perform? A minus B is equal to A plus -1 into B, and I showed you how to do this thing by means of this example. I hope, dear students, it is clear that how to perform the difference of matrices. Now let us understand what are the different properties of matrix addition, and that is the discussion for our next topic, that properties of matrix addition. So as you see, dear students, the properties of matrix addition follow the commutative law. That means what? That means A plus B is equal to B plus A, where A and B are the matrices of the same order. It also abides by the associative law, that is A plus B plus C is equal to A plus B plus C, where A, B, and C are the matrices of the same order. Existence of additive identity. What is that? That means if I have a matrix A, okay, and corresponding to this matrix, I can find another matrix O, okay, so that if I add A with O, and which is equal to the addition of A with O, and that gives me the matrix A, then we can say that the O matrix that is called the zero matrix is the additive identity. So, for example, A is a matrix of order m by n, then the additive identity should also be of the same order of m by n. Correct? So I can give you a little bit explanation on this thing. For example, I have a matrix of something like this, 1, 7, 8, 2, -3, 9, suppose. And what I'm going to do is that I'm going to add another matrix with it, and that matrix is that, what? It is a null matrix, 0 matrix, 0, 0, 0, 0, 0, 0. And that is actually equal to, as it is, we know the matrix addition is commutative. That is the first point we have learned. Then what we can write? That is equal to 0, 0, 0, 0, 0, 0 plus that matrix, that is 1, 7, 8 and 2, -3, 9. And if we add them, what we are going to get? We are going to get the same matrix, that is 1, 7, 8, 2, -3, 9. So that is what we can call this zero matrix as the additive identity. Now, the next one is called the existence of additive inverse. Let me use a different color so that you can make a difference and contrast as well. Existence of additive inverse. Let A be a matrix of order of m by n. Then, for that matrix A, we can find another matrix minus A, so that if we add these two matrices A and minus A, it will give me back, that is the additive identity matrix, that is the null matrix, the zero matrix. If this happens, then what we can say? We can say minus A is the additive inverse of A and vice versa. Means we can say A is the additive inverse of minus A. So, for example, if we take this one only, that as an example, so, if we take this matrix, that is 1, 7, 8, then 2, -3, 9, then what will be the additive inverse, With this one, I am going to add another matrix, okay? So what is that matrix? That I'm going to write in another few seconds. But the resultant will be a null matrix or zero matrix, 0, 0, 0, 0, 0, 0. And dear students, that what will be the entry in this matrix? It will be exactly the opposite sign of the corresponding elements of this matrix. Otherwise, we cannot get the resultant matrix as zero matrix, no? So what we are going to get? We are going to get here -1, -7, -8, -2, 3, and -9. So this matrix now, this matrix, what you see, dear students, this matrix is actually known as the additive inverse of the matrix which is there in the left hand side. So symbolically, if we represent that matrix as A, then this matrix would be represented as -A. So what we get? A plus of -A is equal to the zero matrix or null matrix. So what we can say? From here we can say that -A is the additive inverse of A. -A is the additive inverse of A and vice versa. And the inverse is also true. Means the additive inverse of -A is A. Means we can say that A is the additive inverse of -A. I hope these fundamental properties related to the matrix addition is clear to you? Then the next property what we are going to discuss, dear students, is called the properties of scalar multiplication of a matrix. So what is that we are going to discuss now here? Suppose we have two matrices A and B are of the same order. Two matrices we have A and B and are of the same order. And now we are defining two scalars K and L. We are defining two scalars K and L. So, things go good if we take an example. Suppose we have a matrix A. Let's take a matrix A of order 3 by 2, because so many times we have taken an order of 2 by 3. So let's now take 3 by 2. That means it will have 3 rows and 2 columns. So 1, 7, 8, 2, 4, 6. So it is a matrix of order 3 by 2. In the subscript what we read 3 cross 2, that means that signifies it is a matrix of 3 by 2. Though it is not required to be written explicitly. Now, suppose another matrix B is something like this. 5, 1, 9, and 3, minus 2, 8, for example. These are the two matrices. Now, there are scalars. Scalars is what? K and L. These are two scalars. So, it says that the first property says that K into A plus B is equal to K plus KB. That means what? If we take the value of K as equal to, suppose 3, suppose we are taking the value of K is equal to 3, so 3 into A plus B, that means 3 into A plus B is the matrix what? 1 plus 5, 6, 2 plus 3, 5, 7 plus 1, 8, 4 minus 2, 2, 8 plus 9, 17, and 6 plus 8 is 14. And whatever we are going to get, so we are going to get the matrix something like this 18, because we understood the scalar multiplication of a matrix. So each and every element of the matrix will be multiplied by that scalar. That means 18, 15, 24, 6, 51, and 42. Now this is what we get. Now what this property says that if we multiply 3 into A and 3 into B, we should also get the same thing. That means what we are going to do now, 3 into A plus 3 into B. Let me write properly. Plus 3 into B. So what is 3 into A? 3 into A is something like this. 1, 2, 7, 4, 8, 6. Plus 3 into B. What is the B matrix? 5, 5, 3, 1 minus 2, 9, 8. Now if we go ahead, what we are going to get? 3, 6, 21, 12, 24, and 18, plus 15, 9, 3, minus 6, 27, and what we get is that 24. And if we add them, what we are going to get? We are going to get this matrix 18, 15, 24, 6, 51, and 42. And if you see, dear students, both the matrices, this matrix and this matrix, both are same. Though it is quite obvious to follow, but still I took time to explain you exactly. In the same manner, the second property tells, dear students, is that K plus L into A is equal to K plus LA. In the way what I did the previous property, you can take the same approach to prove the next property as well. Correct, dear students? Now the next point what I'm going to discuss is called the matrix multiplication, and extremely important. So listen carefully about the matrix multiplication. Matrix multiplication is a very, very important topic, and we should be knowing it very well. And I will explain you, first by example, and then we'll go to the theory. And any point of time, at any doubt if you have, you can always raise it to me. So dear students, what is matrix multiplication? Matrix multiplication means is that I have two matrices, and then what I'm going to do, I want to multiply these two matrices and I want to get a resultant matrix. We have done today, earlier classes, we have done addition of matrices, difference of two matrices. Similarly, we are going to do now multiplication of two matrices. Now, if you remember, when we did the addition of two matrices, multiplication of two matrices, there are some preconditions. That means those conditions first has to be valid so that we can perform the addition. For example, what was the condition for matrix addition? Suppose we have two matrices A and B. Under what condition we are going to add them? The condition is that the order of both the matrices has to be same. Like, matrix multiplication also has a condition, precondition. And first we are going to learn about that condition. Suppose we have a matrix A, and the order of the matrix A is m by n. And suppose we have another matrix B, and its order is p by q. That means the matrix A is of order m by n. That means that it has m number of rows and n number of columns. And order of the matrix B is p by q. That means it means the matrix B is having p number of rows and q number of columns. Now, under what condition that matrix multiplication possible? Now, under these circumstances, what we can say is that we can conclude that AB, that is the matrix multiplication, AB is possible if the number of columns in the matrix A is equal to the number of rows in the matrix B. If number of columns, so I can write down number of columns of the matrix A is equal to number of rows of the matrix B. That means what? In simple term, in context to the discussion we are having, number of columns of the matrix A is what? N, and number of rows in the matrix B is P. That means N has to be equal to P in order to have A into B a matrix A into B possible. And what will be the order of the matrix A, B, you know? That means if n equal to P holds true, that means if the number of columns in the matrix A is equal to the number of rows in the matrix B, once this condition holds true, then we are able to do A into B, multiplication of these two matrices. Then what will be the order of this matrix? The order of this matrix AB will be what, you know? AB will be of number of rows in the matrix A by number of columns on the matrix B. So for example, you know, let me use a different color pen. Suppose we have a matrix A of order 2 by 3. And I have another matrix B of order 3 by 4. Then what will happen if we multiply these two matrices is possible? Why? Because the number of columns in the matrix A, which is 3, is equal to the number of rows in the matrix B, which is 3. Then what will be the order of this matrix AB? It should be 2 by 4. Why 2? As it is the number of rows in the matrix A, and why 4? As it is the number of columns in the matrix B. Let's take another example. You know, suppose we take a matrix called, suppose, C. C is a matrix of order 4 by 7. And D is another matrix of order 7 by 2. Then what will happen, dear students? First, C into D is possible or not? Yes, it is possible. Why it is possible? Because the number of columns in the matrix C, which is 7, is equal to the number of rows in the matrix D, which is 7. So C into D possible. And what we can say from here? What will be the order of this matrix CD? Order of the matrix CD will be the number of rows in the matrix C, that is 4, by the number of columns in the matrix D, that is 2. Now, so this is the way we see the matrix, multiplication, how the order actually gets changed. Now let's see some, other type of examples before we exactly come to the procedure of matrix multiplication. What is that? Let me use a different color. Suppose we have a matrix A of order 2 by 3. Then and another matrix B of order 3 by 2. Then what will happen here? A into B possible. A into B possible, and what will be the order of the matrix AB? That should be 2 by 2. I hope all of you understood why it is 2 by 2. Now, is BA possible? BA is also possible. Why? If you look into it, this case, the number of column in the matrix B is 2, which is equal to the number of rows in the matrix A, that is 2. So possible. BA is also possible. And what will be the order of the matrix BA? That will be the number of, BA we are discussing. So 3 by 2. So number of rows in the matrix B by the number of columns in the matrix A, that is 3 by 3. Now let's look into the first example of A by B, what we discussed. Okay. AB is defined in this case. AB is defined. But BA, is it defined? Let's first see. In order to have BA to be defined, we need to find what is the number of columns in the matrix B, that is 4. And what is the number of rows in the matrix A, that is 2, which is not equal. As the number of columns in the matrix B is not equal to the number of rows in the matrix A, so BA is not defined. Or we can say BA is not possible. You really cannot find the value of BA. Let me write properly. BA is not possible. Now let's look into the next one, that CD. Is DC possible? Let's see. What is the, in order to have DC possible, you need to find the number of columns in the matrix D, which is 2. And what is the number of rows in the matrix C? That is 4. 2 is not equal to 4. As the number of columns in the matrix D is not equal to the number of rows in the matrix C, we say that DC is not possible. DC is not possible. Whereas if you see in this case, the another example what we took for AB, we see that both AB is possible and BA is also possible. So dear students, it is very important that under what condition you are going to take a decision that matrix multiplication is possible. I hope it is absolutely clear. Now we can go ahead and to perform the exact multiplication. For example, if I take a matrix A of order 2 by 3 and another matrix B of 3 by 2, let's see how that matrix multiplication is actually takes place. And after that, we will come back to the theory, because first we need to understand with examples exactly how it happens. After that, we will go back to the theory, and so that once you go to the theory, then you will understand, oh, it is so easy. Absolutely, it is very clear. So let's take an example. Suppose we have a matrix A which is of order 2 by 3. That means it has 2 rows and 3 columns. So 2 rows and 3 columns will be a matrix of something like this. Suppose I say it is 2, 7, 8, 1, 5, 4. That is a 2 by 3 matrix. And let's take the matrix B. It is 3 by 2. That means it has 3 rows and 2 columns. So suppose it is 3, 1, 9, 2, 3, 6, suppose. So now how that matrix multiplication is happening? Very important, dear students. Concentrate and you'll understand very easily. So the way the matrix multiplication happens is something like that I will go from matrix A row wise and I will come down in the matrix B column wise. That means what? What I'm going to write now, AB. AB is my resultant matrix now. So how we are going to find AB? AB I'm going to find something like this. As I go in the along the row of the matrix A and along the column of the matrix B, how we are going to get? If you see the first row 2, 7, 8 in the matrix A and the first column of the matrix B is 3, 1, 9. So the corresponding elements will get multiplied and then get added. That means what? It is 2 into 3 plus 7 into 1 plus 8 into 9. That is the element in the first row, first column of the matrix AB. Then comes to the second one. That means first row, second column elements of the AB should be what? So first row wise it will be as it is, and it will be the second column, the 2, 3, 6. This column we will take. So what it will be? It will be 2 into 2 plus 7 into 3. Understood? Because this 2 and this 2, this 2 and this 2, then this 7 and this 3, and then this 8 and this 6. So corresponding elements is actually getting multiplied. Correct, not dear students? So 2 into 2 plus 7 into 3 plus 8 into 6. And then in the resultant matrix, element at the junction of the second row and first column, to obtain that, we need to take the second row of the matrix A and the first column of the matrix B, corresponding elements will multiply. That means 1 into 3 plus 5 into 1 plus 4 into 9. In the similar manner, we can find the element at the junction of the second row and second column, like 1 into 2. That is 1 into 2. Why 1 into 2? Second row of the first matrix and second column of the second matrix. So that is why 1 into 2 plus 5 into 3 plus 4 into 6. So now, if you recall, dear students, the order of the matrix A by B, AB should be what? 2 cross 2, and that's what happened. Now, we need to just simplify it and find it out. Let's simplify it. So what we are going to get from here, we are going to get AB is equal to 2 into 3, 6 plus 7 plus 72. That is the first one. Then 4 plus 21 plus 48. That is another element. Then 3 plus 5 plus 36. That is another element. Then 2 plus 15 plus 24. That is another element. So now we can find it out. So how we can find it out? If you see, now it's just a matter of simple addition. 6 plus 7 plus 72. 6 plus 7 plus we are getting 85. 85. Then the second one will be, it is 73. 4 plus 21 plus 48, that is 73. And 3 plus 5 plus 3 plus 5 plus 36, that becomes 44. And 2 plus 15 plus, what is that? This is 24, and we get it as 41. So this is the resultant matrix. Correct, dear students? The matrix A is having 2 rows, 3 columns. Matrix B having 3 rows, 2 columns. So A into B is defined, and it is having 2 rows and 2 columns. We can also find BA, by the way. Let us find BA, okay? And then it will be, clear. Okay. So let me do BA here in a different color pen. Let me do it here. Let me do it here itself. Yeah. So let me first, we are going to find the multiplication BA. So, so if we need to find that BA, so what is that? BA is that, let me first write the matrix B. What is that? It is 3, 2, 1, 3, 9, 6. And what is this element? Here is that 2, 7, 8, 1, 5, 4. Now we are going to multiply this B into A. First we see that B into A is possible. Why? Because the number of columns in the matrix B is 2, which is equal to the number of rows in the matrix A. Hence BA is possible. But how to find that value of BA? For that, what you will do? Again, let me do slowly. For the first one matrix, here is its B. I will go row wise, and for the second matrix A, I will come down column wise. And we will do what? Corresponding elements will multiply and then add. So fine. How to perform this one? So to perform this one, what we are going to get is that it is 3 into 2 plus 2 into 1. 3 into 2 plus 2 into 1. That is the element in the first row, first column of the resultant matrix. Then what will happen? That 3 into 7 plus 2 into 5, that is the first row, second column element. 3 into 7 plus 2 into 5. Then the first row, third column element of the resultant matrix would be 3 into 8 plus 2 into 4. Now let's come to the second row. Let's how to populate the second row of the resultant matrix, for that we need to go through the second row of the first matrix, that is the matrix B, and the corresponding elements in the right hand the second matrix, that is matrix A. So what it will be? It will be 1 into 2 plus 3 into 1. This is the element of the second row, first column of the resultant matrix. Then 1 into 7 plus 3 into 5. That is the element in the second row, second column of the resultant matrix. Then 1 into 8 plus 3 into 4. That is the element in the junction of the second row and third column of the resultant matrix. Now let's come to the third row. For the third row, what you need to do? You need to take the first matrix and come to the third row, and you will go with the first column, then second column, then third column to have the three elements in the third row of the resultant matrix. That means for the element in the junction of the third row and the first column of the resultant matrix, so what you need to do? We need to go along the third row of the first matrix, that is matrix B, and the first column of the second matrix, that is A. That means here we are going to get 9 into 2 plus 6 into 1, and here we are going to get is that 9 into, so to get the element in the third row and second column of the resultant matrix, what you need to do? We need to go along the third row of the first matrix, that is the matrix B, and that is the matrix, that is third row, and the second column of the second matrix, that is the matrix A. So then what we are going to get? 9 into 7 plus 6 into 5. Then in the same manner, the element in the third row and third column of the resultant matrix is obtained like that 9 into 8, which is the multiplication of the first element of the third row of the first matrix, that is 9, and the first element of the third column of the second matrix, that is 8, plus what we are going to get is that 6 into 4. And as you see, this resultant matrix is having 3 rows and 3 columns, which is perfectly fine according to our understanding. Now all is remaining is that just to find the compute this matrix. So 3 into 2 is 6 plus 2, that is the first row, first column element. Then 21 plus 10, that is the first row, second column element. Then 24 plus 8, that is the first row, third column element. Then 2 plus 3, that is the second row, first column element. Then 7 plus 15, that is the second row, second column elements. Then 8 plus 12, that is the second row, third column element. Then it is 18 plus 6, that is the first row, third column element. Sorry, third row, first column element. Let me write it properly. So 9 into 2 is 18. 18 plus 6, that is the third row, first column element of the resultant matrix. It is 63 plus 30, that is the third row, second column element of the resultant matrix, then 72 plus 24. That is in the junction of the third row and third column of the resultant matrix. Now after that, it is just simply calculation. 6 plus 2 is 8, 21 plus 10 is 31, and 24 plus 8 is 32. Then 2 plus 3 is 32, right properly. 2 plus 3 is 5. 7 plus 15 is 22. 8 plus 12 is 20. It is 24. It is 93. And here it is 96. So this is the resultant matrix of BA. So I hope you got a fair amount of idea that how matrix multiplication is actually getting performed. Now let us come back to the, let's have a look into the theory. What is that? So as I said earlier, now if you go back to the theory, if we read it, then you will have a complete understanding. So what is this, dear students? That multiplication of two matrices, multiplication or product of two matrices A and B are possible only if the number of columns of the matrix A is equal to the number of rows of the matrix B. Second point, symbolically it is represented. If the matrix A is represented at Aij m cross n and B is Bjk n cross P, then AB should be of m cross P. And Cik, how it is being performed, it is actually represented in the summation notation, symbolic representation, and exactly this is the way it happens. Okay, there is an example, and if you look into the example, you will completely make sense out of it because we have discussed in elaborately. Now, the third point, what you see, the next point, the fourth point, if two matrices A and B are such that AB is defined, then it is not true that BA must have to be defined. We have seen an example. We have seen an example here, couple of examples in fact. You see here, dear students, that here A is a matrix of order 2 by 3 and B is a matrix of order 3 by 4. We see that AB is defined, but BA is not defined. Similarly, we see another case, CD. C is a matrix of order 4 by 7, D is a matrix of order 7 by 2. Then we see CD is defined, which is of order 4 by 2, but DC is not possible, not defined. Why not defined? Because the number of columns of the matrix D is not equal to the number of rows of the matrix C. Again, there are other examples where we see both AB and BA defined. Suppose here in this case, the matrix A is of order 2 by 3 and matrix B of order 3 by 2. Then we see that AB is defined, which is of order 2 by 2, and BA is also defined, which is of order 3 by 3. And we have also experienced this by means of a representative example here, you see. So that these all actually signifies that yes, why you are making this statement. If two matrices A and B are such that AB is defined, then it is not true that BA must have to be defined. That means BA may be defined, may not be defined. If AB is defined, then BA may be defined, may not be defined. There is no such restriction that BA has to be defined. Correct, dear students? Okay. Now we are going to discuss, the other points, quickly, because we all discussed all these points. But I want to, just show you this, theory portion so that you can later, along with, my video lectures, you can also follow this statement in future anytime. By the way, all this will be available in future in the online learning platform and online test platform at www.KonarClasses.com. Now, if you see here, if A is a matrix of order m by n and B is a matrix of order p by q, then both AB and BA will be defined if and only if n is equal to p and q is equal to m. AB will be defined for the condition n equal to p and BA will be defined for the condition q equal to m. We have seen this thing. If two matrices A and B are such that A plus B and AB are defined simultaneously, then A and B both are square matrices of the same order. That is quite obvious because A plus B is possible when the number of rows of the matrix A is equal to the number of rows of the matrix B and number of rows of the number of columns of the matrix A is equal to the number of columns of the matrix B. Now what happened is that if A into B is also defined, then what is that? Number of columns of the matrix A should be equal to the number of rows of the matrix B. Let's elaborate it. Let's deep dive a little bit on this. Suppose we have a matrix A of order m by n and a matrix B of order p by q. And what is given to us? That A plus B is defined. A plus B is defined. A plus B is defined. The moment it is informed to us that A plus B is defined, what we can conclude? Number of rows of the matrix A is equal to the number of rows of the matrix B, that is m equal to p, and I can write and here actually, and number of columns of the matrix A, that is n, is equal to number of columns of the matrix B, that is q. Now again if we see that now along with A plus B, AB is also defined. If AB has to be defined, then what is the condition has to be true? Is that number of columns of the matrix A, which is equal to n, that should be equal to the number of rows in the matrix B, that has to be p. Now let's look into it. Now let us concentrate on all these simple equations. If we just concentrate on these simple equations, what we are going to see? We are going to see that m is equal to p and p is equal to n. M is equal to p and we see that n equal to p, so p is equal to n. Again, n is equal to q. So that means what? M is equal to n is equal to p is equal to q. That means what? Both A and B has to be a square matrix. So this implies what? If we say M is equal to n is equal to p is equal to q, suppose we assume this is equal to, suppose S. Suppose if we take say as S, then what happens? A is a matrix of order S by S and B is a matrix of order S by S, and which is a square matrix. That's what has been informed here, dear students, in this point. If two matrices A and B are such that both A plus B and A into B are defined simultaneously, then A and B are both square matrices of the same order. Now the next point, dear students, if A is a matrix of order m by n, and if both AB and BA are defined, then B is a square matrix. B is a matrix of order n by m, obviously. It has to be followed from the other statements what we discussed. If two matrices A and B are such that both AB and BA are defined, then generally it is not true that AB has to be equal to BA. This means that it may be possible that both AB and BA is defined, but still AB is not equal to BA. We have seen this. We have taken an example where AB, A, and here is the example. If you see, dear students, here, if you see that A is a matrix of order M2 by 3 and B is a matrix of order 3 by 2. You see that AB and BA both are defined, but they are not equal. AB is a matrix of 2 by 2, BA is a matrix of 3 by 3. So that's why that is because of this third point has been mentioned here. Not third point, this point has been mentioned here. If two matrices A and B are such that both AB and BA are defined, then generally it is not true that AB is equal to BA. This means it may be possible that both AB and BA are defined, still AB is not equal to BA. Correct, dear students? So now we already seen examples of matrix multiplication. So here also I am showing you another example which you can follow, and make yourself practice once our class is done. Okay, you can also follow this thing and practice and make yourself comfortable there. Yes, whatever Sir has mentioned here, it is actually getting executed like this. Then the point is that whenever AB is equal to BA, this is a terminology, this is a new point. What I'm going to tell you, dear students, is that whenever AB is equal to BA, the matrices A and B are said to be matrices A and B are said to be commutative. So let me clearly explain you. Whenever AB is equal to BA, the matrices A and B are said to be commutative. If AB is equal to minus of BA, the matrices A and B are said to be anti-commutative. Okay. And the next point what I'm going to tell you, dear students, is that if three matrices A, B, and C are such that both AB and BC are defined, then A into BC is equal to AB into C, and that is known as the associative law. And I'm going to show you here, dear students. If you see, dear students, here, if three matrices A, B, and C such that both AB and BC are defined, then A dot BC should be equal to AB dot C, and this is known as the associative law. For three matrices ABC of the same order, if A is equal to B and AC is equal to BC, but the converse is not necessarily true, that you can experiment with examples. Now let us concentrate on distributive law. If three matrices A, B, and C such that all the products AB, AC, and BC are defined, then we can conclude the first one is that A into B plus C is equal to AB plus AC. And second one is that A plus B into C is equal to AC plus BC. And that is what we call as it as a distributive law. Now, the next point what I'm going to discuss is that, dear students, is that I'll take another few minutes to complete that matrix multiplication topic. And here it is. For every square matrix A, there exists an identity matrix I of the same order such that I into A is equal to A into I is equal to A. Okay. For every square matrix A, there exists an identity matrix I of same order such that I into A is equal to A into I is equal to A. What is identity matrix, dear students? Identity matrix is something, if you recall, let me give an example here. Okay, for this I can give an example. Suppose our matrix A is something like this, 2, 3, 1, 7. Then is a 2 by 2 matrix. So what will be the 2 by 2 identity matrix? it is 1 0 0 1. We discussed in the last class about identity matrix. You can follow that video lectures, which is available in YouTube. So now if you multiply, what you are going to get, and this will be equal to the 2317, which is a 2317, which is a, and that also you can write as, this is equal to 2317 and 1001. Now the next point is that if A and B be two matrices such that AB is equal to a null matrix, zero matrix, then it is not necessarily true that either A equal to zero matrix or B is equal to zero matrix. Let's take an example. That it is possible to get a zero matrix as a product of two non-zero matrices. Okay, so for example, this is one non-zero matrix. This is also non-zero matrix, but if you see their product is a zero matrix. You have just learned about matrix multiplication. Once the class is done, once you make some practice, you will see that if you do this matrix multiplication by your own, you will find that multiplication of these two matrices, as you see in the left hand side, is going to be a null matrix, that is a zero matrix. So now, dear students, we are almost done. Now, few points I would like to mention about the matrix multiplication. These are the terminologies, generally comes in the, JEE main and advanced kind of examination, and that I would like to, mention here. And the first one is that the nilpotent of index P and idempotent. So let me first bring the point here and then I'll explain. So dear students, if you look into it here, a matrix A is said to be nilpotent of index P if P is the least positive integer, so that A power P is a null matrix. I repeat, a matrix A is said to be a nilpotent of index P, okay, if P is the least positive integer, so that A power P is equal to a null matrix or zero matrix. And the second point, dear students, our matrix A is said to be idempotent if A square is equal to A. I repeat, a matrix is said to be idempotent if A square equal to A. So with this, we are done with matrix multiplication, dear students. And what I will suggest you, please, go through this, class note, what I'm going to share after the class, thoroughly, along with the video lectures. And, please log into, this website, as I say. All of you have account there, www.KonarClasses.com. Once you log in, then first appear for DPP, that is daily practice problem. Then we appear for PT, that is for practice test. And you will see that you are preparing for both your board examinations and for your entrance examinations. Solving DPP will help you to score great marks in your board examination. At the same time, prepare your foundation strongly. And practice test will help you to, prepare very well for your entrance examinations. After that, I will explain you about that UT, that is called unit test. Then it is coming MDT, that is known as the module test. And then finally, it is coming the MT, that is called the mock test. And all these things are available in the online platform at www.KonarClasses.com. And I will strongly recommend you, dear students, so please visit this website. And those who are attending the class but do not have login, please be in touch with me. You can contact me here. Let me write down my our email ID. It is contact@KonarClasses.com, or you can WhatsApp us as 809501067. In this number you can WhatsApp, and you will get all of your queries get clarified if you have. With this, I would like to conclude the class, dear students. Thank you very much for attending the class. I see there are so many students attending today. Thank you very much. All right.
Thank you, sir. Thank you, sir.
Thank you very much. Take care.